Okay, YouTube, this will be a short introduction on operations with radicals. Students seem to be doing this chapter, at least locally, so what I'm going to do is work a few problems and hopefully answer some questions. Our first is to simplify the square root of 75. What I want to do is I want to factor out perfect squares from my radical. So I'm going to basically prime factor 75 with perfect squares in mind. So what I'm going to do is I'm going to change this to 25 times 3. Now what I can do is separate this into the square root of 25 times the square root of 3. I can do that because I'm multiplying in a product. The square root of 25 is 5. Radical 3 stays under the radicand, and this is the simplified version. If I want to add radicals, I have to make sure that what's under the radicand is equal. Now sometimes you may have something like 2 root 3 plus the square root of 75, and I would have to factor the square root of 75 to 5 root 3 before adding them. So what I'm going to do is I'm going to add what's outside of the radicals. 2 plus 3 is 5. Now I don't change root 3. This is 5 root 3, right? And to illustrate that, I can let u equal root 3. This is called u substitution. Now I have 2u plus 3u equals 5u, and then what I do is I substitute root 3 back in for u. That equals 5 root 3. At this point, u substitution may just make things a little more complicated, but feel free to use it as you will see it in later mathematics courses. If I want to multiply a radical times a sum, I have to distribute, just as I would a variable or a constant. So everything here is positive. Root 2 times 3 root 2 is 3 times the square root of 4 plus, keep my sign, 7 radical 2. Square root of 4 is 2. 2 times 3 is 6 plus 7 radical 2. And this is the simplified version. There's nothing, I can't add these two. I can put this into a calculator, but it's going to give me an estimate. So if your test or if your assignment says simple radical form, this is it. If it wants you to round, I would put this into my calculator, 6 plus 7 root 2, and I would get a decimal approximation and round that. If I want to multiply a sum and a difference involving radicals, I use FOIL. You may recognize FOIL from multiplying binomials. Same concept. 3 times 2 is 6. That's the F. First times first. O stands for outside. That's 3 times negative root 5. So that's minus 3 radical 5. So that's sort of the outside. I stands for inside. 2 times root 5 plus 2 root 5. And L stands for last times last. The square root of 5 times the square root of negative 5 is going to be minus, right, the square root of 25, which is 5. So what I have here is 6 minus 5 is 1. Negative 3 root 5 plus 2 root 5 is negative 1 root 5, which is the same as 1 minus the square root of 5. And that's simple radical form. If I'm dividing radicals, but I do not want to start by dividing these two numbers. what I want to do is I want to again factor these. So 500 is 100 times 5. The 125 is the square root of 25 times 5. Square root of 100 is 10. 10 root 5 divided by, what I do is I pull out the 5, right? The square root of 25. This is the same, just the denominator is the same as the square root of 25 times the square root of 5. So this is 5 root 5. Now in this case I can cancel these. Square root of 5 divided by the square root of 5. And that leaves me 10 divided by 5 equals 2. And that's the simplest form. That will not always happen. Well, if you have the same number, you can cancel them out. But if this is 5 and this is 3, there's not much you can do with that. So that I just wrote that so they happen to cancel. Okay. This last one is what's called rationalizing the denominator. We don't want radicals in the denominator, although sometimes on tests like the SAT or the ACT, you will see radicals in the denominator as correct choices. When we're doing arithmetic, when we're doing algebra, we want to move that in the numerator. So what we do is we multiply by a form of 1. And I can multiply anything times 1 without changing its value. So what I'm going to multiply by is what's called the conjugate pair of root 7 plus 2. And the conjugate pair is root 7 minus 2. And I need to have the exact same thing top and bottom, or else I'm going to change the value of this expression. So what I get is my numerator, root 7 minus 2. Now when I FOIL these, I picked this so that my outsides and my insides will cancel. And let me show you what happens. First times first, the square root of 7 times the square root of 7 is the square root of 49, or 7. Now this is plus 2 root 7 and then minus 2 root 7. So those cancel. That's by design. That's why we pick the conjugate pair. 2 times negative 2 is negative 4. So when I multiply a radical sum by its conjugate pair, I will always get a number minus another number. So 7 minus 4 is 3. This is root 7 minus 2 over 3. Or you could write it negative 2 plus root 7 over 3. Okay, I hope that was a short review. I know it's not totally comprehensive, and it doesn't go over every possible problem like this. They do get somewhat more complex, especially when you get into cubed roots and fourth roots, sort of higher order roots. But as an introduction, hopefully this helped, and feel free to leave questions in the comment section, or to go ahead and message me with any questions you might have. Thank you.